Let's talk about ellipses today. Ellipses are one of the conic sections, and they're one that's used quite a bit in terms of mathematical modeling because it represents the path of some kind of an orbit of an object. We're going to start by taking a look at these right cylindrical cones that we've got here. And you can see that they're kind of like two ice cream cones, tip to tip. As we're cutting the cones with a plane, and you can think of a plane kind of like a piece of paper, we can slice it and get an elliptical shape, a very, very common shape for an orbit. If we go through this cone perpendicularly, so straight through, not diagonally, we end up with a circle. If we do a vertical slice straight through, we end up with a hyperbola similar to a parabola, but it's got two branches to it. And then finally, if we come through it at a diagonal, we end up with our parabola. So just kind of a brief overview there. The ellipse is a really nice one to work with though, because it is a common path for lots and lots of orbits. Let's go ahead and take a look at standard form. So standard form for the ellipse, it's a lot like our transformation form. X minus h squared divided by a squared plus y minus k squared divided by b squared is equal to 1. This has center h comma k. Similar to how we would find a vertex for a parabola, but now both the x and the y are thought of as inputs, so we end up changing the signs on the h and the k. We can also establish orientation, which is the direction of these, either by being horizontal. Horizontal means that the parabola lengthwise is longer, horizontally left to right. This would be the case if the denominator on the x term, a squared, was bigger than the denominator on the y term, b squared, or we could have vertical orientation. And this would be if b squared was greater than y squared. So it's determined by the bigger denominator. Vertical orientation looks like this. We're not going to look at any that are on a slant orientation. Okay, so we've got our center. I'm going to go ahead and go through this for a horizontal orientation. Our center is going to be placed the same regardless of orientation. If I'm working on a horizontal orientation, that means that my major axis, the longer one, is horizontal. So this is my major axis, the longer one, and this one is my minor axis. In the vertical orientation, they're flipped. The major axis is vertical and the minor is horizontal. The endpoints of the major axis are called vertices. So we can continue. So vertices equal endpoints of the major axis. And we get to these in two different ways depending on the orientation. So if we have horizontal orientation, we're going to get to that in the x direction. So we're going to take the center and we're going to add a. The number that's associated with the x term is going to be the distance center to an endpoint in the x direction. So h plus a, and I could really say plus or minus a comma k. This would be a vertex. If we're in the vertical direction, it's going to be a change in the y direction. So we want to get to our vertices by going up and down. So that's going to be k plus or minus, and then its distance is b. And this would equal a vertex. We also have endpoints, if I can spell. So endpoints of the minor axis. I'm just going to say PTS of minor. Again, it depends on the orientation. If it's horizontally oriented, the endpoints of the minor axis are changes in the y direction. So that's going to be, we're going to leave, let's see, this is horizontal. So we're going to leave h, and then we're going to change k plus or minus b. If it's vertically oriented, and when I go through some examples, it's going to make more sense. If I'm vertically oriented, here it is, and I need to change in the x direction. So that's going to be h plus or minus a, comma, b. Finally, we've got the foci. The foci are another way to geometrically define an ellipse. Foci can be used to draw it geometrically. We can attach a string focus to point on the ellipse to another focus, and then stretch the string and draw it around in a circle, or in an ellipse, I should say. But the foci also have really important properties when it comes to light waves and sound waves. I'm just going to give you the formula, and we'll be finding those also as we go through our examples. So finally, distance, center to focus, and there are two of them, f is equal to the square root of the absolute value, a squared minus b squared, and then we use that to get from the center to the focus. The order doesn't matter, a squared minus b squared minus a squared. You just want to make it positive on the inside. Let's go through some examples. I think the examples are easier to follow along through than the formulas make it seem like. Okay, so here comes our first example. First question is, what's the orientation? Well, I just look at my denominators and I decide which one's bigger. It's the x, which means that I have horizontal orientation. So right off the bat, I know that my major axis is going to be in the horizontal direction. My center is going to be in the middle. My vertices are going to be at the endpoints. And my foci always live on the major axis. Foci. Okay, so a ton of information based on orientation. The center point, I could write those numerators as x minus 0 squared and y minus 0 squared. I don't need to, but I do need to recognize that there's nothing added or subtracted. So that tells me that my center point is at 0, 0. Distance center to vertex. Well, we've already established that this one is horizontal, which means it's in the x direction. So that tells me that I need to pick up the denominator of the x term. So a is the square root of 25, which is equal to 5. This is in the x direction. So if I want to get to a vertex, I've got to go 5 in the x direction from the center. Okay, so 1, 2, 3, 4, 5. There's one of my vertices. And then 5 in the negative x direction gets me to another vertex. Distance to the end of the minor axis. Well, since this one is horizontal, that means that my minor axis is in the y direction. Center is here. Center. The endpoints that I'm looking for are there. So to get that distance, I just need the y's denominator. So this is going to be my y denominator. B is the square root of 16, or 4. So I need to travel 4 from the center. 1, 2, 3, 4. 1, 2, 3, 4. And I have what I can put together as an ellipse. And I'll just warn you, I'm not a great ellipse drawer. But if I go kind of slow, it's not so bad. Okay, not bad. I'm missing the foci though, and I know they're going to be between the center and the vertices. So let's go ahead and find our foci. I'm going to do this in red as well. So foci is the square root of a squared minus b squared. So I'm going to subtract those denominators. 25 minus 16. Square root of 9 is 3. So those foci are 3 away from the center. 1, 2, 3. There's a foci. 1, 2, 3. There's another foci. Okay, so where are they located? They've got x coordinates of 3 and negative 3. So we could say plus or minus 3, comma 0. Or we could split those up, 3, comma 0 and negative 3, comma 0. Okay, so a little easier in practice, right, than all of those formulas. For this one, we're given the ellipse, and we want to come back and get to all the properties from that given graph. I'm going to start with the center and orientation. I can see that my major axis is vertical. So this one has vertical orientation. So I can already label anyway my center and my vertices. Center point is, again, at the origin, makes it really nice. Distance center to vertex, that's going to be 1, 2, 3, 4. Distance center to the end of the minor axis. Let me grab my green pen, draw on my minor axis. And those endpoints are 2 away. There's one endpoint, I'm just going to call him E, and another endpoint. So that distance is 2. Center to focus. So let me go back to that formula. Square root of a squared minus b squared. I need a and b. So I've got the distance centered to the vertex. This is in the y direction. So that guy's going to be a b. It doesn't matter if you call it a. B is 4, which means that b squared is 16. What I'm really doing is I'm putting together my fractions. Underneath y squared would be 16. Doesn't matter if you call it a or b. Underneath x squared, this happens to be the minor axis. A is 2, so a squared is 4. But what's important is that you end up with a 4 in the denominator. Okay, so now I can finish this. Distance center to vertex. So the focus is the square root of 4 minus 16. This absolute value right there. So that's going to be the square root of 12. There is a perfect square in 12. It's a 4. Radical 4 times 3. Let's see, the square root of 4 is 2. So that's going to be 2 radical 3. So distance is 2 radical 3. That looks nice, but it does not help me graph at all. So let me clear this, and let's do a 2 radical 3. 2 radical 3 is about 3.5. So let's put that also here. So it's about 3.5. To get to my foci, they're located 3.5 away from the center. So I want to keep the x the same. So as I label these, it's going to be 0, comma, plus or minus 3.5. Or we could label that as 0, comma, I'm going to do my 2 radical 3 just to remind us what the exact values are, minus 2 radical 3. Okay, and the equation. We actually pretty much had it right there next to part B. Do you see that equation? I'm going to go ahead and draw this in purple. X squared over 4 plus y squared over 16 equals 1 is our equation, squaring the distance to the vertex and the distance to the minor axis for those denominators. Okay, here comes our next one. First of all, orientation, vertical or horizontal. This should be the easiest step. I'm just looking for the bigger denominator. There it is, and it's with the y, so that means it's vertical. So already putting this into action, I've got the center, my vertices, and my foci, even though I don't know exactly where all of these things are all going to be in the vertical direction. Puts a lot of nice things in motion. It's also telling me that my minor axis, I'm going to draw this guy in green, is in the horizontal direction. Okay, center point. Center point is going to be that h comma k. So center point, I need to change my signs, is 1 comma negative 2. 1 for x, negative 2 for y. So there's my center point. Distance center to vertex. Well, to go to the vertex, I need to travel in a y direction. So that's going to be the square root of 9. So b is the square root of 9, which is 3. The b doesn't matter. Just make sure that you're grabbing the 9 to get to its square root of 3. In the y direction is the most important thing. Let's go ahead and draw these in. So 1, 2, 3. There's a vertex. 1, 2, 3. There's a vertex. Distance center to the end of the minor axis. The minor axis is in the x direction, so we need to grab the number underneath the x term. So this is going to be a. Again, you don't need to label it. Just know it's the square root of 4 or 2. Okay, 1, 2. There's an endpoint. I'm going to call it p this time. 1, 2. There's another endpoint. I'll call it p this time. And I'm just going to draw this in, kind of, sort of. Again, I'm not the best ellipse drawer. That kind of sort of works. Let's do distance center to focus. I'm going to do this in red. This is the square root of a squared minus b squared. And we just want to make sure that's not negative. So it's the square root of 9 minus 4, radical 5. So that distance is radical 5, which is great for an exact answer, but I would really rather have a decimal so I can graph this guy. Square root of 5 is about 2.2. So, or about 2.2. Okay, so to get my foci, I need to move in the y direction, 2.2. So it's going to be 1, 2.2, 1, 2.2, foci. So as I'm labeling my foci as points, I'm going to keep the x fixed. I'm only moving in the y direction. And my y was a negative 2, but I needed to both add and subtract, go up and down, radical 5. Okay, again, this is kind of nice if you want an exact answer, but we can also put this into the calculator. So we can go negative 2 plus radical 5, and that's going to be the upper foci, focus, 0.23. And then let me just grab this and change it to a minus in between, minus. So we have negative 4.2 and 0.2. So this is going to be 1 comma negative 4.2 and 1 comma 0.2. Okay, so we've got our foci, we have our vertices and our endpoints. The only other thing I want to do is to label them. So I've got my foci here. So 1 comma 0.2, 1 comma negative 4.2. My center was 1, negative 2. I'm not going to label that one just because I'm going to be out of room here. My vertices, that's going to be 1, 1, and then 1, negative 5. And then the endpoints of my minor axis, these are in the x direction. So I do change my x's. So this is 3 comma negative 2. But I do not change those y's. Negative 3 comma negative 2. So we've got everything labeled. Next, our second topic is converting to standard form. We're going to be doing a lot of completing the square. If you didn't quite have the hang of completing the square before, I think you will when this is done. Let me go ahead and write down our goal again. So x minus h squared divided by a squared plus y minus k squared divided by b squared equals 1. Our first goal as we're completing the square is to gather up all of our x terms and all of our y terms together. For this first one, there's just a single x squared. So there's actually nothing to complete the square on for the x's. So I'm just going to kind of pull that along. But I do want to combine my y terms, and I need a lead coefficient of 1. So we are going to factor out any coefficients that we have on either the x squared or the y squared. So as I put this together here, 4y squared minus 8y, other thing that I want to do is to move that to the other side, that 96. Okay, so it's starting to look like my standard form. X's are together, y's are together, constant on the other side. Oh, and this should be a squared. Let's go ahead and factor out the lead coefficient. I'm only completing the square on the y's for this one. So as I factor out the lead coefficient, this 25x squared stays put. The 4 factors out in front, and I get y squared, 8 over 4, I get minus 2y. I'm ready to complete the square there, equals 96. If I'm adding to the left side, I better add something to the right side to keep it balanced. Here comes the complete the square step. Half of -2 is -1 squared. -1 squared is 1. But I didn't just change this side of the equation by 1. I changed it by 1 times 4. So I write both of those there on the line. Continuing to get this closer to standard form, 25x squared plus 4. Let's go ahead and factor this trinomial. And I always use this number here. Y minus 1 squared equals 96 plus 4, which is 100. I'm almost there, but I need a 1 on the right side. So finally, I divide everybody by 100. This is going to get me to my standard form. So I'm going to write this in purple. Let's go ahead and simplify. 25 over 100 is 4. So I get x squared over 4 plus 4 into 100 is 25. Y minus 1 squared over 25 equals 1. So we can see that we've got a vertically oriented ellipse, and our center is 0, 1. But this is our answer right here. Okay, let's do the next one, number 2. So for number 2, I do have both an x term and a y term. So I do want to go ahead and start by grouping all of my x's and all of my y's together. So 4x squared minus 16x plus y squared minus 2y, and let's bring the 13 over, equals -13. I'm going to group these. Lead coefficient is already a 1 for the y's, so I'm good there. But I do want to factor out a 4 to get a lead coefficient of 1 for the x's. So as I factor that 4 out, I get x squared minus, cancel these, 4x. That's ready to complete the square, plus y squared minus 2y, also ready to complete the square, equals -13 plus blank plus blank. 2 things I'm going to be adding this time. Now let's complete the square. Half of the middle coefficient, half of -4 is -2. We square that to get 4. In the second one, I'm going to take half of -2, which is -1. We square that to get 1. On the other side, I added a 4 that was multiplied by a 4. So I write both the factor out in front and my completing the square number on that line. For the y's, I just did the 1. Nothing was out in front. Okay, ready to factor this. 4 is still out in front. I'm going to factor my trinomial. X, and I always look at my work there. I'm going to grab that -2. It works every time. X minus 2 squared plus nothing out in front. So this is going to be y minus 1 squared equals -13 plus 16 is 3 plus 1 is 4. I'm so close. I'm almost there. If we go back and peek up at standard form, we have everything except the 1 on the other side. So let's go ahead and divide everything by the 4 on the right, and we'll do that on this side as well. Okay, so here comes our answer. 4's cancel, and I've got x minus 2 squared. You can write this over 1. 1 is the distance of center to the end of the axis in the x direction. So that 1 I think is really helpful to have there. Plus y minus 1 squared all over 4 equals 1. There's nothing else we need to do, just getting to that standard form. And that goes up on that line there. Okay, next one, number 3. Hopefully these are getting better. Nice and consistent. You do quite a bit of completing the square in calculus. It comes up just enough where you're going to want to be good at it, because usually when it comes up, it's in some really big problems. Let's go ahead and do the x terms. So I get 9x squared plus 18x. And then my y's plus 4y squared minus 40y. And let's bring the 73 to the other side, equals -73. Then I'm just going to run through and with parentheses group my terms. I do have lead coefficients on both the x and the y that are other than 1. So I want to divide out by those. So I'm going to divide by the 9 and then divide by the 4 for the y's. Taking the 9 out in front of my x's leaves me with x squared plus 2x. I'm ready to complete the square here. The 4 comes out in front of the y's, and I get y squared minus 10y plus blank equals negative 73 plus blank plus blank. Okay, completing the square. Half of 2 is 1 squared is 1. But I actually added a 1 times 9. So I'm going to write both of those on the line. That's times. And then half of negative 10. Half of negative 10 is negative 5. Squared is 25. But I actually added 25 times 4. 4 times 25. Let's go ahead and factor what we've got. The hard part, I think, is over. So I get 9x. I'm going to use that plus 1. Squared plus 4. It was a minus 5. So y minus 5 squared equals, now I need negative 73. I'm gonna let my calculator do the work here. Okay, so negative 73 plus 9. And I know that that's 100 plus 100. 36 equals 36. I need a 1 right here. So I'm going to divide everything by a 36. Grab my purple pen because I'm pretty much there. 9 over 36 is 4. X plus 1 squared divided by 4. 4 over 36 is 9. So plus y minus 5 squared over 9 equals 1. And that's our standard form equation for number 3. I think we've got one left. One left. Okay, let's do it. So one left. We're going to collect our x's, collect our y's, get the number on the other side to start. So here are our x's. So 9x squared minus 90x. Put parentheses around those. And then my y's plus 25y squared plus 50y, parentheses around those, equals negative 25. I'm going to factor out those lead coefficients. So I'm going to factor out a 9 and a 25. This is going to give me, 9 comes out in front, x squared minus 10x plus blank. And then for my y's, 25, y squared plus 2y plus blank equals negative 25 plus blank plus blank. Okay, here we go. Half the middle coefficient. So we do half of negative 10 is negative 5 squared 25. But we actually did 25 times 9. And I'm just going to write that here, 25 times 9. Next one, half of 2 is 1 squared is 1. But that wasn't just 1, that was 25 times 1. 25 times 1. Okay, almost there. Let's go ahead and factor it. 9 is out in front. X, I'm going to use my number from my complete the square work. Minus 5 squared plus 25. Y plus 1 squared is equal to, I don't know. So negative 25 plus 25 times 9 plus 25 equals 225. Okay, that's kind of nice actually. So equals 225. I'm almost there. I'm so close. I just need to divide everybody by 225 to get 1 on the right. 225. Grab my purple pen. This gives me 9 into 225. You can do that right on your calculator. You get 15. Oh, not 15, 25. So x minus 5 squared over 25 plus my 25 actually is going to cancel. Let me undo that, and I get y plus 1 squared. 25 into 225 is 9. And again, you can just do that right on your calculator, equals 1. Okay, just to summarize, this one has horizontal orientation. Center is at 5, -1.